How many different real number prime factors does 120 have? Okay, here's the key. It says different and it actually underlines it. Different, okay? So they have to be different numbers, different real numbers. So let's take 120. Prime factors. So prime. Is 2 a prime number? The only way to achieve 2 is 1 times 2, right? So 2 is prime, and does it divide nicely into 120? Okay, take your calculator and take 120 divided by 2 if you need to. 120 times, good, you're helping me out. Okay, now we're going to take 2 and we're going to break 2 apart. Or we're going to break 60 apart. Let's use 2 again. 2 times what gives you 60? 30. Okay, it's even. Let's use it again. 2 times what is 30? Okay, 15 breaks into 3 and 5. These are all examples of prime numbers. So I have 2, 2, 2, so 2 to the third, times 3, times 5. How many different real numbers, it says, do we have? 1, 2, 3. Correct answer is H. When you're done writing it down, flip to the back side. Okay, so number 1 is not necessarily hard, but it gets a little messy. Which of the following lists the factors of 60? So that means how do we achieve 60? So 1 times 60. So make sure we have a 1 and 60. Okay, this doesn't have a 1, cross it out. 1 and 60 doesn't have a 1 and 60, doesn't have 1 and 60. Okay, we're already down to 2 choices by simply doing the very first step. Since 60 is even, 2 times 30. Does this have a 2 and a 30? Yes. Does this have a 2 and a 30? No. Done. Going on to number 2. Which of the following is an odd number that is a factor of 140? Grab your calculator. Well, the first thing it says is it has to be an odd number, so anything that's not odd we cancel out. Take 140 and put it into your calculator right now and divide it by 13. Do you get a nice integer answer? Take 140 and divide it by 35. Do you get a nice answer? Done. Okay, let's go on to the next problem, number 3. How many prime integer factors does 50 have? So let's just first figure out how many factors does 50 have, and then of those, how many of them are prime. So let's take 50. We have 1 times 50, 2 times 25, and 5 times 10. Now of these, I only want to circle prime numbers. So remember, 1 is not prime. Is 2 prime? Yes. Is 5 prime? Yes. 10 is not prime, 25 is not prime, and 50. You have 2 numbers that are prime integer factors. I had wonderful help from people in my first hour that were able to explain this in a quicker manner. So please read number 4 to yourself. I read it out loud. If a and b are positive integers less than 1, such that the greatest common factor of a cubed b and b squared a squared is 36, then which of the following could a be equal to? So it says the greatest common factor is 36. So the biggest number, remember greatest common factor here, is 36. So for this problem, we're going to use the answers and we're going to plug them back in to realize that the correct answer is K. Now let me read it from the actual book to you to see if this wording is simpler than how I would state it. Okay, it says we're going to use the answer choices as our strategy. Try each answer choice for A to see which could work. Choices F, G, H, and J, when plugged in for A, produce too large of a number that would allow a number larger than 36. So for instance, 36 squared is greater than 36, right guys? And 36 cubed is larger than 36, right? Can't be that. Do you agree 18 squared, without even doing the math, and 18 cubed is larger than 36, correct? Let's try 9. 9 squared is 81. 9 cubed is 729, greater than 36. 6 squared is 36. Hey, that works. But 6 cubed is 216. It's greater than 36. 3 is the only one that works. 3 squared is 9, and 3 cubed is 27. That's the only choice that is less than or equal to 36. Okay, coming down here to number 5. If a, b, and c are different odd prime integers, how many factors does 2 times a times b times c have? Okay, again, a, b, and c are odd prime integers. So I'm just going to use some examples. You ready? Let's go with 2. Do you guys agree that 3 is, odd prime? I didn't say 2. I know 2 is prime, but it's not odd. So, and what's the next odd prime? What's the next odd prime? So I'm just going to associate these numbers with here, okay? All right, ready? 2 times 3 is 6. 6 times 5 is 30. 30 times 7 is 210. Okay, you guys are going to help me break this apart. You ready? Here we go. So 1 times 210. 2 times what gives you 210? So take 210 right now. Divide it by 2 for me. 105. Can you please check? Take 210 divided by 3. What do you get for an answer? Take 210 and divide by 4. Tell me if it's a nice number. Yes or no? Okay. Take 210 divided by 5. 42. Take 210 divided by 6. Does it work? What is it? Take 210 divided by 7. And I know that 10 has to work. Try 8, 9, but I know 10 has to work. 8 and 9 don't work, I believe. Try 10. So 210 divided by 10 would be 21. Okay, so we have our numbers here. Now it says how many factors? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. I'm missing 2. Try 14 times 15. Does that give you 210? I missed those 2. 14 times 15. So there is a total of 16 factors.